All right, sixth graders, so this is our last lesson for chapter 5. Factor the expression using the GCF. We need to remember what GCF is an acronym for. Greatest common factor. I'm just going to write that down that way. A factor, remember, are numbers that can go into another number. The factors of 8 are 1, 2, 4, and 8 because those are the numbers that can evenly go into 8. When we're talking about common factor, we're looking at 2 or 3 different numbers, trying to find the biggest possible number that can go into both. Now, 8 plus 16. Well, I know, thinking from my 8 times tables, that 8 and 16 both show up in my 8 times tables. So the greatest common factor of 8 and 16 is 8. So since that's the biggest number that can go into both 8 and 16, 8 is going to go outside my parentheses. Then I think, well, what is 8 divided by 8? Well, 8 divided by 8 is 1. And then I'm going to do 16 divided by 8, and 16 divided by 8 is 2. I'm just going to put a plus sign in here, and that's all you do. And mathematically, if you want to check it, 8 plus 16 is 24. And then I think to myself, well, 1 plus 2 is 3, and 8 times 3 is 24. Now 90 and 80, I know that they are both divisible by 5 because they both end in 0. Okay? So I'm going to come down here and I'm going to say, well, how many times can 5 go into 90? Well, 5 can go into 9 one time. 1 times 5 is 5. 9 minus 5 is 4. Bring the 0 down. 5 can go into 40 8 times, and I know there's none left over. So, because 5 times 8 is 40. And if I do the same thing, 5 going into 80, 5 can go into 8 one time. 1 times 5 is 5. 8 minus 5 is 3. Bring the 0 down. 5 can go into 30 6 times, and I know there's none left over because 5 times 6 is 30. So, since 5 was my common factor, I'm going to put 5. And then I'm going to say, well, 90 divided by 5 was 18. 80 divided by 5 was 16. I'm going to put my minus there. But there's something that I always need to check for when I do these problems. And that is basically whatever you have in parentheses essentially needs to be in simplest form. When I go back to my first one, I ended up with 1 plus 2 because 8 divided by 8 was 1, 16 divided by 8 was 2, and the only number that can go into both 1 and 2 is 1. So this tells me this was as small as it can be. But when I come down to this problem, 18 and 16, and a lot of you probably caught it while I was doing it, but that's the joy of making a video. I can just keep on going because nobody's here to interrupt me. You probably realize that, well, Mr. Swack, both of these end up in a 0, so that tells me that 10 would be the greatest common factor, or at least a bigger common factor. And when I look at 18 minus 16, I realize, you know what? That is not in simplest form. There is a number besides 1 that can go into both 18 and 16. And they're both even. That ends in 8, that ends in 6. So they're both divisible by 2. So I can think of that as, well, now I've already got a 5. I can't get rid of that 5. But now I'm also going to put a 2 out there because I'm going to divide both of these by 2. And 18 divided by 2 is 9. And 16 divided by 2 is 8. And I end up with 5.2, which is 10, and then with 9 minus 8 in parentheses. So my final answer actually needs to be 10 with 9 minus 8 in parentheses. And when I factor them, I'm not solving anything, but I can double check my math. I know that 90 minus 80 equals 10. And this is 10 times whatever 9 minus 8 is. Well, 9 minus 8 is 1, and 10 times 1 is 10. I need to make sure what's in my parentheses is in simplest form, that the only number that can go into both of them is 1. When I go to this one, 80 plus 75, well, this ends in a 0, this ends in a 5, so I'm going to start with 5. I'm going to come over here, see how many times 5 can go into 80, okay? And I'm going to cheat a little bit. I remember doing that problem here. That's why it's always good not to erase your scratch work. 5 can go into 80 16 times, so I know that was right before, so I'm just going to put it there for this one. But then I want to take 5 going into 75. Well, 5 can go into 7 once. 1 times 5 is 5. 7 minus 5 is 2. I'm going to bring down that 5. 5 can go into 25 5 times. And I know there's none left over because 5 times 5 is 25. So that tells me that it's 5 and then 16 plus 15. There's no number besides 1 that can go into both 16 and 15. That tells me that this is as simplified as it's going to get. 75 minus 39. Well, here's an interesting one, and this is where you want to remind yourselves of those rules of divisibility. I'll probably go ahead and post those rules of divisibility again for this lesson. They might help you. But that ends in 5, but this does not end in 0 or 5, so 5's not going to work. They're not even numbers, so 2 is not going to work. But when I add the 7 and the 5, that makes 12. 12 is divisible by 3. When I add the 3 and the 9, that's divisible by I get 12. That's divisible by 3. So I know that both 75 and 39 are divisible by 3. I just need to figure out what numbers are going to go there. I'm going to go 3 into 75. I'm going to do that right here. 3 can go into 7 twice. 2 times 3 is 6. 7 minus 6 is 1. I'm going to bring the 5 down. 3 can go into 15 5 times. I know there's none left over because 3 times 5 is 15. So for the 75 divided by 3 is 25. I'm going to do 39. And I'm going to divide that by 3. And as a 6th grader, I should be able to realize, well, 3 can go into 3 once, and there's none left over. 3 can go into 9 3 times, and there's none left over. And that tells me that this should be 13 with a parentheses. 25 and 13, there's no number besides 1 that can go into both 25 and 13. So that's going to be as simple as that expression can get. All right, now the second part of what you're going to do now incorporates some variables into it. It's not going to change what we do. Like in this first example, 3x plus 9, I'm still going to think, well, 3 and 9. The biggest number I can think of that can go into both 3 and 9 is 3. So that's going to be what goes outside my parentheses. Well, 3x divided by 3 just leaves me with x. Just like 3 times x gives me 3x. Then I do 9 divided by 3. Well, 9 divided by 3 gives me 3. Bring my addition sign down. I get x plus 3. 16x plus 20. Okay? When I think about my multiplication tables, I think, well, I think these are both divisible by 4. So I'm going to put 4 outside my parentheses. 16x divided by 4. Well, 16 divided by 4 is 4, but I also have to include the x in my answer there. 20 divided by 4 is 5, so I'm going to have plus 5, and I think that's in simplest form because no number besides 1 can go into both 4 and 5. To check if this one was in simplest form, remember our rule. If there's no number in front of a variable, we know that there's a 1 there. We don't put the 1 there, we just understand that it's there. So we have 1 and 3. No number besides 1 can go into both 1 and 3. Moving right along, 60 plus 85x. Well, to start, I see that this ends in a 0, that ends in a 5. So I'm going to start with a 5 outside my parentheses because I know they're both divisible by 5. So I'm going to come over here, 60 divided by 5. 5 can go into 6 once. 1 times 5 is 5. 6 minus 5 is 1. Bring the 0 down. 5 can go into 10 twice. And I know there's none left over because 5 times 2 is 10. So for the 60, I know that I have 12. Then I got to do 85 divided by 5. So I'm going to come over here, 85 divided by 5. 5 can go into 8 once. 1 times 5 is 5. 8 minus 5 is 3. Bring down the 5. 5 can go into 35. 7 times. There's none left over because 5 times 7 is 35. I end up with 17. But don't forget that my x needs to become part of that. So I have plus 17x. I believe this is in simplest form because no number besides 1 can go into both 12 and 17. Last one, 81y plus 72x. Well, when I think of 81 and 72, the number that comes to mind is 9, because I know that 9 times 9 is 81, and that 9 times 8 is 72. So the number that's going to go outside my parentheses as a common factor is 9. Now 81 divided by 9 is 9, because as I said a few seconds ago, it's 9 times 9 that makes 81, but my y needs to be part of my answer. Also, 72 divided by 9 is 8, as I mentioned before. It's 8 times 9, that's 72. So I'm going to put the 8, but the x needs to become part of my answer. Okay? And really, it's not an important detail. It's just some bonus information. When we do problems like this, if we can, we try to put the variables in alphabetical order. So really, if you have an algebra teacher, they're probably going to want you to put 8x plus 9y and put the x first. But I know I can flip an addition problem and it doesn't matter. So I think that's in simplest form because the only number that can go into both 8 and 9 is 1. And that is my final, but really either one of those can be considered correct. All right, have a good day, 6th graders. That's the end of chapter 5. Bye.